In this session, we are going to see about the heating effect of electric current. Consider the electric appliances like a toaster, which convert the electrical energy into heat energy. How the electrical energy is converted into heat energy. So, in this lesson, we are going to see about the heating effect of electricity, identify the cause of heating effect of electricity, and illustrate the working of an electric fuse, state and derives Joule's law. Consider an electric circuit. The circuit is connected with a bulb. When the switch is on, the bulb is glowing. This is because a filament which is in the bulb is called tungsten filament, through which the current is passing. The metal conductor gets heat. So that heat which makes the bulb to glow. And another appliances which is based on the heating effect of electric current is electric iron box, in which the coil which have a high heat, and room heater and water heater. See how the electrical energy can be converted into heat energy. So in this circuit, consider a battery is connected with switch and bulb, and the current is flowing through the conductor. So the conductor which offers some resistance to the flow of current, and the electrons which drift from the negative terminal to the positive terminal. So when the electrons drift towards the positive terminal, which collide with the positive ions. See here, when the electrons is coming out of the atom, it will create the positive ions, isn't it? So the the atom which consists of both the electrons and positive nucleus. Okay, when the electron which is coming out of the atom, so that will make the positive ions. So the positive ions are immobile ions. When the electron which accelerate in the conductor, the immobile positive ions which create the resistance to the flow of electron, so that whenever the electron which collide with the positive ions, the energy is transferred to the positive ions. So the energy required to oppose the resistance, the energy which is acquired by the electron, and the energy which is required to make the flow of current in the circuit against the resistance is called the heat energy. That electrical energy will be converted into heat energy. See, in this model, you just consider a conductor. The conductor is connected with battery, switch and bulb, and whenever the battery is switched on, the current will be flowing in the conductor. That means the flow of electron will exist in the conductor. Now when the electron is coming out of the atom, it will make the immobile positive ions. So those immobile positive ions which oppose the motion of electron. So the electron collide with the positive ions and converts its energy into the heat energy. So we can define that the work done in opposing the resistance of the conductor is stored as the electrical energy, or which is liberated as the electrical energy, heat energy in the circuit. So the electric current has to do some work against the resistance. So that electric current will be converted into heat energy. So here we should consider the heating element. Heating element is nothing but the conductor which is preferred for making the heat or producing the heat in the appliances. So that conductor should have a high resistance. When it have a high resistance, then the flow of electron will be resisted by the resistance of the material. In such a case, the electric current which oppose the resistance of the conductor will be converted into heat energy. So that this is called the conversion of electrical energy into heat energy. And the electric appliances which is based on this heating effect of electric current is toaster, room heater, electric iron and bulb. See, the bulb is made with heating element. The heating element is tungsten. So how we are preparing the good heating element? So the heating element should have a high resistivity, high melting point, and it should have a negligible variation due to the resistance and temperature changes. Okay. See, why a good heating element should have a high resistivity is because whenever it have a high resistance, so that the current will do more work to flow in the conductor against the resistance. See, the conductor which resists the current. So against that resistance, the current is try to move, the electron is try to move in a circuit. So that work done is liberated as the heat energy. So the heating element, what we are using in the toaster and room heater, so that heating element should have a high resistivity and it should have a high melting point. This is because when the high amount of heat energy is produced in the filament should not get melt, so that it should have a high melting point, and this should not vary with the temperature. The resistance of the conductor should not vary with the temperature. So these are the good heating element. These are the points in which a good heating element can be preferred, and those elements are nichrome, manganese and tungsten. See here, nichrome is the alloy of 80% of nickel and 20% of chromium, and manganese is an alloy of 86% of copper, 12% of manganese and 2% of nickel. Then tungsten is the alloy of 60% of copper and 40% of nickel. See, these elements are preferred as the heating element because the alloy of nickel and chromium. Nichrome is the best heating element because the heating element nichrome, manganese, tungsten. So these having very high resistivity as well as high melting point. It will not easily vary with the temperature. So we prefer the nichrome as a heating element. So we are using the water heater in our home. Okay, so the water heater and the room heater which is made up of a coil. That coil is made up of an alloy is called a nichrome. So nichrome is mostly preferred as the heating element. This is because the nichrome have a high resistivity and high melting point. So this is the important question that you can expect in the examination. How we are preferring the heating element. The heating element should have a high melting point and high resistivity, and it should not easily vary with the temperature. And next we are going to see about the electric fuse. See, we can observe the fuse, electric fuse in our main electric board. Okay, so what is the purpose of using the fuse? When we are not using the fuse, suppose at any cost a very large amount of current is passing through the home appliances. So the home appliances may get damaged. So this is electric fuse, and we have a different form of fuse wire. One is fuse wire, next fuse box and fuse bulb. See, this fuse bulb you can observe even in a tube light, and the fuse wire we can observe in the main board. So this fuse wire is nothing but a small piece of wire, that wire which makes the electrical circuits to be safe. And see, this is the fuse wire When a large amount of current is flowing through the circuit, it will get melts because of the heating effect. So the electric appliances can be saved from the external current. So this is the electric fuse bulb, in which we have a small piece of wire. Suppose in this the ability of current to flow is 5 ampere. Suppose the current exceeds the 5 ampere, then this wire which gets melt because of the heating effect. See, much current will produce much heat energy. So due to that, the current will convert into heat energy. That energy will be used for melting of the wire, so that the fuse wire, which is based on the heating effect of electric current. So we have to prefer the fuse with the high resistivity as well as low melting point. This is because when the current is flowing, that is much amount of current is flowing in the circuit, then it has a low melting point, then it will be melt easily through the heat produced in the electric fuse. And consider the electric iron box, in which we can adjust the heat energy maximum to minimum. So in which the amount of current can be controlled. And next, James Prescott Joule, who observed this heating effect of current, and he proposed that whenever the current is flowing through the high resistance material, that electrical energy will be liberated in the form of heat energy. So according to his, the law is called Joule's law of heating. So the amount of heat produced is H is directly proportional to square of current, and directly proportional to resistance of the conductor, and directly proportional to time in which the current is passing. See, from this we can say the Joule's law. The amount of heat energy is directly proportional to square of current and resistance and time. So we have the expression, that is H is equal to I square RT. This is the very important expression which represent the amount of heat energy produced in the circuit. H is equal to I square RT. And consider an electric circuit with electrolytic solution, in which the potential difference V is nothing but the measure of work done in a unit charge across the unit. Already we have seen in the electric potential difference. So according to that, the electric potential V is equal to work done divided by charge, that is W by Q. So from this we can alter the expression for W. So W is equal to V into Q, that is work done is equal to product of potential difference and charge. And electric current which is flows in the circuit, that can be given by I is equal to charge flows per unit time, that is Q by T. So change the expression for Q, then Q is equal to I into T. See, substitute this Q in the equation 1, then you will get W is equal to VIT. See, this is the formula for work done by the electrical energy, or this work done is also referred as energy. So the formula for energy is equal to VIT. Suppose you substitute V is equal to IR in that expression, you will get W is equal to I square RT. So the electrical energy that will be converted into heat energy is given as I square RT. From this we are defining the Joule's law of heating. So the heat energy is directly proportional to the square of current and resistance and the time of passage of current. And next, what is electric power? So the electric power is nothing but the rate of doing electrical work. Okay, so electrical energy is nothing but the work done to move the charges from one point to another point. So here energy is equivalent to work. So work is equivalent to energy. So then power is equal to is also called energy by time. So the rate of doing work or the energy with respect to time, energy divided by time is also called power. So the electrical power is referred as electrical energy divided by time. So already we know that the work done is equal to VIT, and W is equal to is also called I square RT. Then substitute this in the above expression, that is electric power is the work done by time, isn't it? So substitute work done is equal to VIT, then T and T get cancelled. So the electric power formula P is equal to V into I. Then substitute work done is equal to I square RT in the above expression, so that you will get P is equal to I square RT and T get cancelled. Then the power is also referred as I square R. Then after we are getting P is equal to I square R, substitute I is equal to V by R. This is according to Ohm's law. So according to Ohm's law, V is equal to I into R. You change the expression I is equal to V by R. Then you will get P is equal to I square R. Substitute I is equal to V by R. So that V by R the whole square into R. When R and R square get cancelled, finally you get the power formula is equal to V square by R. The SI unit of power, the SI unit of electrical power is watt. This is named after the scientist Watt. And 1 watt is defined as when 1 volt potential is applied to make the flow of 1 ampere current, then it is referred to as 1 watt. And the commercial unit of electric energy is kilowatt hour. See what we are using the current in terms of units in our home. We are referring the current whenever you are seeing the EB bill, in which you can observe that the electricity consumed is given in unit. So what is that unit? That unit is nothing but the commercial unit of electrical energy. Here 1 unit is equal to 1 kilowatt hour. See, normally we have the power that can be represented in we can represent it in kilowatt. So the electrical energy which is used commercially is called kilowatt hour. So 1 kilowatt hour is equal to 1 unit of energy, that what we consumed in our home. See, 1 kilowatt hour is the energy used in 1 hour. See, 1 kilowatt hour is equal to power into time. Here the power is taken in terms of kilowatt and the time is taken in terms of 1 hour. So 1 kilowatt will be equal to 1000 watt and 1 hour is equal to 3600 second. Then you multiply, you will get the total energy 3.6 into 10 power 6 watt second, or also it is referred in joule. So 3.6 into 10 power 6 joules of energy is equal to 1 kilowatt hour. This is the energy we are consumed in our home, that is equal to 1 unit.